Hey students, welcome back. Today we are going to take on the last little bit of gas stoichiometry, or gas laws, and that would be stoichiometry. So rolling on here, we've got gas stoich. This is page 40. Like I said, this is the last part of this unit. So let's jump right in. We've done stoichiometry before, so this is not too new. Remember I said the steps would always be the same. So let's see. We actually have a little addition here, and this little baby is going to make it super helpful. If we are at STP, 1 mole of any gas will equal 22.41 liters. Most of the time we measure gas in a volume like liters, all right, instead of grams, because the grams would be very small. So let's go through and review our stoichiometry steps. The very first step has not changed. Our first step is to write a balanced equation. All right, so we're going to write a balanced chemical equation. Our second step then is to find moles. Now, when we did stoichiometry before, we just did grams, right? When we went from grams, we divided by the molar mass. All right, but this time we now have a volume, right, of a gas. So this time we could also perhaps divide by liters, and let's change that to 22.41 liters. All right, because that'll get us to moles as well because of our equivalent statement above. Step 3 has not changed. This is our mole to mole ratio. And reviewing, remember this is where we put where we're going over where we've been. Okay. And then our last step is finding our unknown. In the first stoichiometry we did, we just did grams, so we multiplied by molar mass, right, to get to grams. But this time we could also be finding liters of a gas, and so we could multiply by 22.41 liters. All right, so let's see what we got and see if we can apply these steps here. Boop. To these examples. So if we read through, we've got sodium azide is used in airbags. It decomposes quickly into its elements. How many liters? We're looking for liters of nitrogen. So our question mark goes under nitrogen and we're looking for liters. And we know we have 3.55 grams of sodium azide. So let's go ahead and put that under there, 3.55 grams of sodium azide. So we're basically going from sodium azide to nitrogen. So going back up here, we've got our first step. We've got to write a balanced equation. So if we look, we've got 1 Na, 3 N's on the reactant side and 2 on the product side. So we've got to fix that part. So we're going to say a 3 here. That gives me 6 N's. So can I get 6 N's on the reactant side? I hope so. If I put a 2 out there. Now I have 2 NAs and we want to balance the NAs. So let's say 2 NAs. So we should be good in balance there. Awesome. Our next step is we're going to find moles. And we find moles since we're starting with grams. So on our little T-chart, let's start with our 3.55 grams. 3.55 grams of sodium azide, NaN3. And we're going to convert that to moles, and we need to do that by doing the molar mass. So kind of our little aside here, we've got NaN3, we've got Na, we have one of those, so we're going to take that times 22.98977. I found that on the periodic table. All right, we have N, we have 3 times 14.00674. So this one was that 22 number. All right, down here, 14.00674 times 3 is going to give us 42.02. And then 022. We're going to add those babies up, and that's going to be our molar mass. We're going to get 65.01 is our molar mass of sodium azide. So we're going to put 65.01 grams of NaN3 on bottom. On top, we're going to put 1 mole of NaN3. All right, grams cancel, grams cancel. Now we're ready for our multimole ratio. We're going to put 2 moles of NaN3 on bottom. This 2 came from that 2 right up there. On top, we're going to put where we're going, which would be 3 moles of N2, because that's what we're looking for. That's where our question mark is. All right, notice how moles cancel there. And then our last and final step says to find the unknown. Since we're going to liters, we're going to use that 22.41 liters, so 1 mole of N2. We are at STP, so we're going to say 22.41 liters of N2. Cross that out. Now we're ready to do our math. Remember on our calculation here, just to make sure we're all on the same page, we're going to take 3.55 times 3 times 22.41 divided by 65.01 divided by 2. All right, and that should give us our answer there. So let's go ahead and do that. 3.55 times 3 times 22.41. Divide that by 65.01. Divide that by 2. And we should get 1.84 liters. All right, 1.84 liters of N2. Now, let's make sure that makes sense to us. We started with 3 grams. Would it make sense to make almost a 2-liter bottle? That seems like a lot, but it's actually a pretty good amount, and that would be correct. So awesome. Okay, let's look to the next one then. Our next question says, how many grams, we're looking for grams, of sodium chloride, that's our question mark, grams of sodium chloride, will be formed when we have 25 liters of chlorine gas. So we have 25.0 liters of chlorine gas and we have excess sodium. All right, and we're at STP. Okay, so the very first thing we do, we have to balance. So let's go through and do that. I'm going to put a 2 right there to give me the same number of CLs. Then I need a 2 in front of Na. And then I need a 1 in front of Cl2. All right, and we're going to start with what we know. So in this case, we're going to start with our 25.0 liters. 25.0 liters, and that's of Cl2. Make our little handy-dandy T-chart. Now, this time we're at liters, so if we go back up to the top, if we're at liters and we're going to moles, we've got to divide by 22.41, so we're going to put 22.41 on bottom and 1 mole of Cl2 on top. This way, liters of Cl2 cancel. All right, our next step is our mole to mole ratio. So we're going to put where we've been on bottom. That'll be that 1 mole of Cl2. Remember, we got that 1 from that 1 right there. We're going to NaCl, so I'm going to put 2 moles of NaCl on top. This way, yep. Okay, that's where we're going. Do some unit canceling. Our moles of Cl2 cancel. And our last but not least step is we're trying to find grams. So to find grams, we're going to multiply by molar mass. So we need, again, kind of a little aside here. We need an aside for NaCl to find that. Let's try that whole part again, huh? That A got a little high. All right, so NaCl, we have Na, we have one of those at 22.98977. And we have Cl, one of those, at 35.4527. So we're just going to add these babies up here to get us our answer and round to the nearest hundredth. So 22.98977 plus 35.4527. And we should get 58.44. 58.44 grams per mole. That's our label. All right. And so we've got 58.44 grams on bottom of NaCl, 1 mole of NaCl on top, or on bottom. Man, Griffith got that mixed up, huh? Hopefully you were following around with what I said instead of what I was doing. All right. So 58.44 goes on top. And so now we're ready to do our calculation. We're going to take 25 times 2 times 58.44, then divide by 22.41. All right, and let's see what we get. 25 times 2 is 50, right? Times 58.44, divided by 22.41, and we should get 130. All right, 0.39 grams of NaCl. All right, and there we have it. All right, see you next time.